Hello, my name is Chelsea Zabowski. I'm a Health Informatics graduate and student at George Mason University within the Department of Health Administration Policy. This presentation is part of the Teach 1 assignment for the HAP 823 course taught by Professor Alemi. I'll be covering question 5 from the Logistic Regression assignment during this presentation. Question 5 says to predict the 6-month likelihood of the first occurrence of a walking disorder instead of death. In this analysis, exclude all assessments that occur after the walking disability has occurred. To rephrase this question, using the patient's assessments, which includes their demographic information and current disabilities at the time of the assessment, predict if the patient is likely to be unable to walk within the next 6 months. We can think of our data as a time series. Every row for an individual patient is a point in time. So looking at this example, patient 51 was able to walk during their initial assessment, but unable to groom. 7 days after patient 51's initial assessment, they were still able to walk, but are now able to groom. 621 days after their initial assessment, they became unable to walk. So we're being asked if 180 days after first assess equals 0, was patient 51 able to walk given their other diagnoses. For their second assessment, was patient 51 able to walk after 7 plus 180 days given their other diagnoses? And 180 days after visit 6 on the 483rd day, was the patient able to walk? In this case, no. 42 days after their 6th visit, which would be day 663, they were unable to walk. What comorbidities may have contributed to that diagnosis? The instructions specifically say to exclude all assessments that occur after the walking disability has occurred. So for patient 51, we would exclude all assessments after day 621. I used R within RStudio to do all my preprocessing and build out my models. To start off with, install and load any packages that you may need in order to do your preprocessing and analysis. Just to highlight a few, Tidyverse is a collection of packages for syntax transformation, data manipulation, graphing, and file reading and writing. SQLDF lets you write SQL code within R. It's good if you're more comfortable with writing in SQL, but you want to utilize other functions and capabilities that R provides. Fast Dummies is a quick way to binarize your data. Next, import the data from whatever local or network drive you're connected to. The raw file does not include column names, so we're going to set those so we know what attributes we're working with. Then we're going to clean the data. First, we'll remove any observations where the age is less than 0. There's 55 records in this data where people have assessments before they're even born. Then we're going to remove the records where a person only had a single assessment. Next, we're going to calculate the age the person was when the assessment took place. We're also going to binarize the gender variable. Finally, we're going to drop the old character gender attribute and the survival attribute. We don't need the survival attribute because we're not predicting death in this question. We're now going to calculate 6 months from the day of the assessment. To do this, add 180 days to the first assessed column. This gives us 6 months out from that appointment day. I titled this new column First Assessed 6 Months Out and put it in a temp table with the same name. Next, we're going to find out the first time the patient was unable to walk. To do this, we filter by records where unable to walk flag is true. Then take the minimum assessment day for that patient. So for example, we can see that for patient 51, the first time they are unable to walk is on day 621. Note that this will exclude patients where they are always able to walk. In other words, all records show unable to walk equals 0, such as patient 10. Patient 10 doesn't show up in our first unable to walk temp table because they were always able to walk during the entire time of the study. They had no days where unable to walk equals 1. For a lot of the patients in our first unable to walk table, they were unable to walk starting on day 0, their initial assessment day. Patient 62 is a good example of this scenario. Next, we're going to create a yes/no flag to determine if the patient was able to walk 6 months following their assessment day. First thing we're going to do is join the table where we have our first assessed plus 180 calculation, the first assessed 6 month out table, with the temp table we just built to see the first time a walking disability occurred, the first unable to walk temp table. We want to do a left join in order to retain the patients that were always able to walk. The first assessed 6 month out table is on the left and the first unable to walk table is on the right. They're joined by patient ID. To create the flag, which I called unable walk 6-month flag, we have to determine if the number of days 6 months from that particular appointment is before or after the first day they were unable to walk. So looking at patient 51 again, we can see that for their appointment on day 483, 180 days after that, they were diagnosed with a walking condition. We know this because 180 days after their appointment on day 483, which would be day 663, 663 is greater than the day they were diagnosed with a walking condition. So for patient 51 on the appointment day 483, they get a true flag for that newly created unable walk 6-month flag column. We then have to account for any instances where unable walk 6-month flag is null. As a reminder, this occurs because the patient was able to walk the entire time of the study period. Patient 36 is a good example of this scenario. Additionally, the assignment specifically asks us to exclude all assessments that occur after the walking disability has occurred. I took care of this request by filtering on records where the first assessment was less than the first time they were unable to walk. This will also exclude patients that were unable to walk on their very first assessment. Next, we're going to derive decades from our age at assessment variable. We're also going to drop any columns we don't need anymore. We only need to keep our independent variables, which include the demographic information, the diagnoses variables, and of course our dependent variable, which we called unable walk 6-month flag. We're also going to distinct our entire data set so there's no duplicates. From here, the pre-processing is going to look very similar to what Julie did for Teach 1 for question 4, so I'll link her video in the description box below. We're just swapping out the dependent variable and using different programming languages. Our next step is to group the independent variables in order to calculate the probability of being able to walk after 6 months, given the combination of demographic information and diagnoses for each patient. So our probability is the number of patients that were unable to walk after 6 months, divided by the total number of patients with that particular combination of diagnoses and demographic information. Our new variable n is the number of unique IDs in that combination group. We're also going to filter out any diagnoses and demographic groups that have less than 10 people. Next, we're going to calculate our logit variable from our probability variable prob and our population count n. This is required because multiple variable regression requires a continuous response. So what this formula is saying is that if the probability equals 0, take the log of 1 divided by n. If the probability equals 1, then take the log of n divided by n plus 1. And if the probability is anything besides 0 or 1, then take the log of the probability divided by 1 minus probability. Next, we're going to binarize our decade variables. We're going to use the function dummy calls from the R package fastDummies that we installed and loaded into our environment at the beginning of this script. Finally, we're going to drop any columns that we do not want to include on our model. We don't need the old decade column since we just binarized it, and we don't need the probabilities or counts of patients because we're using our logit value instead. So we're going to end up with a final data set that has 17 variables: the gender, the 7 decades, the 8 diagnoses groups, and our dependent variable logit. Finally, we're able to run our regression models. In all of our models, the variable that we're trying to predict is logit. So logit will always be on the left side of the tilde. This is an example of a regression model run against the unable to eat, unable to bowel, and unable to urine independent variables. The summary function gives you the output from your regression model. The number of asterisks next to a variable indicates its significance. A p-value below 0.05 indicates that that particular variable is a meaningful addition to your model. We can see that unable to eat and unable to bowel were good predictors of the ability to walk after 6 months, but unable to urine was not a good predictor. We can swap out our independent variables or run our model against all the independent variables, like in this example. That covers it for this part of question 5. Thank you for your time and attention.